Hi everybody, Dr. Jensen with CCJ3701, Research Methods in Criminology. So hopefully you're getting more comfortable in SPSS. You'll notice we're going to move a little bit quicker through some of the labs because we shouldn't have to work click by click through everything. You've run frequencies, you've done recodes by now, and you've started to get more used to navigating SPSS. So we're going to move a little faster, and you also have the luxury of pausing me or fast forwarding or rewinding me. So we should be able to do that okay. But please reach out if I'm just going lightning speed and you're completely lost. I'm happy to provide something to you or help you over the phone or whatever we need to do to make sure you have what you need. So today's lab is lab 5. We're going to be doing a new skill, conditional recodes. So again, this lets you take variables and create new stuff out of stuff you already have. It's really creative, but if you need to, take the moment to set up by going to apps.ufl.edu and launching IBM SPSS Statistics 24 like you usually do and getting your data. Remember, the data you need for this lab is add health waves 1, 2, 3, and 4 merged. The place that data lives is on the R drive. So if you go to Common Files R, and then the Courses folder, the Fall CCJ3701 folder, the Data folder, then you'll actually find the file you need. So pause for a moment and resume when ready if you need a setup. Okay, so let's jump into your lab. Right here. You have a couple different things you're going to be doing with this lab. Let's work on some of the easier things first. So number 1 says use a recoding command on the variable called year to switch the birth years into ages. So let me show you a really cool way to switch around numbers in SPSS if you need to do that. So you'll notice on row 16 you have a variable called year. Now this variable used to be called H1G57 or whatever. Again, if you're the only one using the data, you can save a copy for yourself and you can rename anything you want. Okay, I just changed this one to year because it's their birth year and that was easier for me. But again, you just have to make sure that if you use a code book, you know what it was originally called if you need to go research some information about it. But we're going to take this variable and change it. So let's say you had data that had a whole bunch of birth years and you're like, well, that's fine and dandy, but I really want to know how old everybody is. So this is where you use logic. Okay? Again, we never analyze what we don't know. So we're going to run a frequency of the variable year. Remember, you can flip around the variable labels and names inside the queue to make it easier to find stuff. There's the variable year. We're going to pop it in. Click OK and take a look at this variable. So here's the variable birth year, and you can see these are years 1974 to 1983. Okay, so we know every year the kids in this data set were born, but we want to look at their age. Maybe we're interested in things happening as they get older, and so we don't want the birth year. We just want how old they are. Well, if you know that year 1, right, wave 1 of the data was collected in 1994, then you can figure out how old everybody is. Okay, so let's do that together. If we go to a coding scheme, we're going to use that other stuff in a minute, you can see here that if the data was collected in 1994 and you said you were born in 1974, then basically you got a 20-year-old in there. You just subtract 1974 from 1994. Do the same thing with every birth year and you can figure out that the time they took the survey, which was 94, how old they were. Okay, and you can do this in a lot of ways. So the kids born in 74 were 20 at the time they took the survey. The kids born in 75 were 19, 76, 18, and so on and so forth. So all you'd have to do is do a recode based on this coding scheme. So let's do that one very quickly together and we can answer question number 1. So we're going to go to transform, recode into different variables. We'll grab our variable year. There it is. We're going to go ahead and name it age. So we're not drastically changing the variable, we just want it to be more useful to us. We'll go to old and new values. So a value of 74, for some reason it's just a 2-digit year listed in the data, not a 4-digit, is now going to be a new value of 20. Click add. And you would do the same thing for each number in the sequence. 75 is going to be 19, 76, 18, and continue onward, 77, 17, until you get to 1983. 78 is 16. We do have 11-year-olds in here. We're getting there. 79 is 15. 80 is 14, and we know that's right. 80 is a nice round number you can easily check your math on. 81 is 13. And once you get a big long list, you get a scroll bar. You can kind of scroll down and see where you are. 82 is 12. And 83 is 11. Okay? We also had one other value in there. If we look at the frequency, we had a 96. So we need to take that value of 96, it's representing missing data, and add that to our list as missing. And then anything else that was system or user missing, it was a blank response, we again are going to continue to make system missing and add that one too. So there's our two missing commands at the bottom of our coding scheme. This looks good. Click continue, hit change, whoops, change, and click OK. Now remember, in your output, it just kind of shows the syntax, the raw commands of what you did. You'll need to actually go in and check your work so you can see the new variable. So remember, you can always use the Analyze menu from the Output menu. The whole menu is available in the Data view or the Output view. So let's run descriptive statistics, frequencies. Our original variable year is still in there for convenience. The new variable age is going to be the very last one at the bottom. There it is. Let's put those two side by side. Click OK. We'll run them both together. And we'll go ahead and check our frequency to make sure we're right. So if I had 18 people born in 1974, I still should have 18 people from there that are 20 years old. Okay, so I shouldn't get any new 20-year-olds, right? So this is just going to be the reverse of what was in the original frequency. So again, recoding is really cool. We can check all these. So 8, 579, 903, 1081. Yep, we're looking really good. Okay, so basically we just made data that wasn't as useful to us a little more useful. So now you can answer the question, how many 16-year-olds do you have in this data set? All right, on to the next recode. So back to our worksheet. Create a new variable that represents individuals who are lesbians and gays. And I gave you some variables to use. Now this is where you would go in a data set and try to find some variables that would be useful to provide information to determine maybe a characteristic, a identity, or an attribute about somebody. This actually came from a student who wanted to work on this topic. They were interested in lesbians and gays and offending, and they were also interested in children of lesbians and gays, as far as whether they were more or less delinquent than children of heterosexual couples. And so this is a really interesting topic, but they went into the Ad Health data set and they couldn't find a variable that told people what your sexual orientation was. And so we had to use a bunch of other variables to be able to determine that. So again, this is where you have kind of logic. This information about you would tell me that information about you. So we're going to do a lesbian variable and a gay variable. So before we get started, it says use the variable biosex4 for gender and number of men and women slept with in the last year to create a condition for your recode. So basically it goes back to logic. If we know your gender and we know the men or women you are sleeping with in the last year, we can pretty much determine your sexual identity, right? You can see who's gay, straight, and so forth. So that's all we're really doing here. Okay, so let's run some frequencies, get to know the variables that we're playing with here. So we need, actually I'll show you a shortcut that'll keep things really easy. Go inside your lab and copy and paste the name of that H4SE17 variable. And we're going to actually run frequencies with raw commands so that we don't have to scroll forever trying to find this stuff. This is a really great shortcut. So go to File, New, Syntax. When you open up a syntax editor, you get a blank little screen that looks like this. And all you have to do is type in frequencies, and SPSS says, oh, it looks like you're typing the word frequency, and you say yes. Type in the word variables, and again it suggests, are you typing variables? Yes. Equals, now you can paste in that little name of that variable. Okay, we want to run frequencies on all of these, so let's go copy and paste the next one. H4SE23, go back into our syntax editor, hit a space, paste that variable inside, and now we'll go back to our lab, grab the name of the last variable, biosex4, which all it stands for is what's your biological sex in wave 4 of the data. Hit a space, paste that one in. All you need to do is put a period on the end, and you'll notice it changes color, which basically says SPSS, this is a function that's ready to go. So we're actually going to run 3 frequencies, all these variables at the same time, without having to navigate and scroll and pop stuff in the queue and stuff like that. Highlight this script once you have it written, and click the play button. Ta-da! So this is a very convenient way to navigate data sets that have thousands of variables in them and you don't want to sit there and have to pick stuff out. This is called syntax. All it is raw commands, kind of like HTML, where you can run functions in a program without having to go through the file menus. That's it. Okay, so what do we got here? This first one says number male partner last year. So on the very left we see 0 partners, 1 partner, 2 partners, 3 partners, and then how many people answered those responses, the percents and so forth. Okay, so this is number of male partners you had in the last year. Here's the next frequency, number of female partners you had in the last year. 0, 1, 2, 3, 4, 5. And you notice the male partners, it goes all the way up to 75. And then the female partners, it goes up to 50. Okay. And then at the very bottom, we have biological sex. Whoops. Biological sex, male and female. What's nice is we don't have very much missing data on here unless they just skipped the question. So we actually have some good data on biological sex. So now we've gotten to know all the variables we have. We're going to write up our coding scheme now of how we're going to use this information to create a variable called lesbians, a variable called gays. All right. So I wrote up a little coding scheme in advance so you can kind of use this. Let me just answer a quick question that a lot of people have. Why do you make us write these little coding schemes? I don't get it. Here's why. Because when you get ready to present your research to an employer, a boss, or anything like that, you have to show them how you did it. So if you changed anything in the data and you have to explain how that worked, your coding scheme is going to be your roadmap of the changes that you made. So we're going to practice later on in the semester how to take something like this and write it up into some plain English sentences. So you can describe to someone some of the steps you took in changing the data prior to analysis. It's kind of like showing everybody your cards. This is what I did, this is what I had, so you're as transparent as possible. We love transparency in research, so someone can replicate what we did and get the same answer. But you're going to do this in your final paper too. So the reason we go through it in these steps is this is the very same process that you're going to follow when you start recoding your own variables for your own paper. All right, so let's work on our lesbian variables first. So here's our coding scheme. So the old value of 0, meaning I'm not sleeping with any women, we're going to continue to say is 0. If you slept with 1 or more women, we don't care if it was 1 woman or 50 women or 10 or 23, we just want to know if you are sleeping with women, we're going to make that a 1. And then again, if it's system or user missing, we want to continue to make that missing. Okay, but then we're going to add a little twist. Okay, let's go to the biosex variable really quick. Biosex says that a 1 is a male and a 2 is a female. Okay, in that question that asked how many men or women are you sleeping with, it didn't ask their gender. It just asked how many men or women are you sleeping with. So we don't really know who's with who. Okay, so we're going to use this gender variable to say if you are female and you report sleeping with females, then you are lesbian. Okay, we're going to create these conditions, recode the variable in just a moment, but I will continue that on our next video. See you then.